Good morning, everyone. I'm Miss Johnson. I'm the math teacher, and I'm here to review adding fractions with unlike denominators. So today we're going to start with the fractions 2/5 and 2/3. And we're going to go over the rule that when adding and subtracting fractions, you always need to have common or the same denominators. In this case, the denominators are a 5 and a 3. So we need to make them common. We have to find a common denominator. So what we're going to do is we're going to make a T-chart and find the least common multiples of 5 and 3. The least means the smallest common multiple. So you're going to count by 5s for multiples, you're going to count by 3s and see which number they both have in common, the smallest one that they both have in common, because they might have more than one. So I try to do about 5 or 6 numbers. So in this case, I'm going to always start with the biggest one. 5, 10, 15, 20, 25. So I'm doing my multiples or my skip counting. And then I'll do my 3s. 3, 6, 9, 12. If I get stuck, I'll do my dice dots. 13, 14, 15, and I'll tap them. 16, 17, 18. Okay, so I always do my biggest common denominator. I go across and I say, do they both have a 5 in common? No. Do they both have a 10 in common? No. Do they both have a 15 in common? Yes. So 15 is my least or my smallest common multiple. Okay, they both have the same or common multiple. So now I'm going to go up here and find equivalent fractions with the denominator of 15. Okay, so the rule is when you're finding common denominators, you multiply the bottom and the top by the same number. Whatever you do to the bottom, you do to the top. And my students always say that. Whatever you do to the bottom, you do to the top. So 5 times 3 equals 15. So you'll do the same thing to the numerator. 2 times 3 equals 6. So there's my new equivalent fraction. 2/5 is equivalent to 6/15. So now I'm going to take the denominator 3 and I would have to multiply it times 5. 3 times 5 equals 15. So I will multiply the numerator also by 5. 2 times 5 equals 10. Now I have a new problem. This is my new problem. 6/15 plus 10/15. I now have two fractions with 15 as the common denominator. There's my 15. You keep the same common denominator when adding fractions. The rule is you only add the numerators. So 6 plus 10 is 16. 16/15 is the answer to this problem. It is an improper top-heavy fraction. So if you were in 5th grade and they asked you to put it in lowest terms or to reduce it, then what you would do is say, oh, well, I'm always looking at that denominator. I'm dealing with 15s. Every 15 is another whole number. 15/15 is 1 whole. 30/15 is 2 wholes. 45/15 would be 3 wholes. So I'm going to subtract out my first whole number, 15/15, to get a proper fraction or mixed number. 16/15 minus 15/15 equals how many 15s? 16 minus 15 is 1. So I subtracted out 1 whole and I got 1/15 left over. So 16, I'm in your way, sorry. 16/15 equals 1 whole with 1/15 left over. 1 and 1/15. If I needed to show this on a number line, I could. I will demonstrate that with a smaller number. But I can look at that and say 16/15 is between 1 whole and 2 wholes. 16/15 is between 15/15 and 30/15. So I know it's going to be 1 whole and some left over in a fraction. So let me try another one. Okay, so let's try 2/3 and 1/2. First thing we're going to look at is the denominators. And we're going to say, oh, they're not the same. They're unlike. So I need to find common denominators. I always deal with the biggest denominator first. So I make my T-chart to find the least common multiple, the smallest common number that they both have when counting, skip counting, and using the multiples. So I'm going to do the 3 always first because it's bigger, then the 2. And I'm going to skip count or find the multiples. 3, 6, 9, 10, 11, 12, 13, 14, 15. And then I'm going to find the multiples or skip count by 2s. 2, 4, 6, 8, 10, 12. Then I will always look at the top row first and say, do they both have a 3 in common? No. Do they both have 6s? Oh, they do. But wait a minute, they also have 12s. And I'm going to say, oh, but I need the least, or the smallest common multiple. So 6 is smaller than 12. I'm going to go with the 6 as my denominator. Would you still get an answer if you use the 12? Yes, but we want the least. So we will use the 6 as our common denominator. And we're going to find equivalent fractions using 6 as a denominator. Again, whatever you do to the bottom, you do to the top. So 3 times 2 equals 6. So 2 times 2 equals 4. 2 times 3 equals 6. So 1 times 3 equals 3. So now I have my new problem with my 2 fractions with common denominators. My common denominator is 6. So the rule is now I can add the numerators. 4 plus 3 is 7. So now what can I do? 7/6 is the answer, but it is a top-heavy improper fraction. So what am I going to do? I'm going to look at that denominator and say, oh, I can count by 6s. Every 6 is a whole. So what am I going to do? I'll do it 2 different ways. If I was asked to show work on a test, I would know if the denominator is 6, then I need to count by 6s. 6, 0, 6, 1, 6, 2, 6. I'm trying to make sure each part is equal distance apart, each increment or part. So number line is my favorite choice of drawing pictures. It's easier than area models for me to make each part as equal as I can. 0, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6. So I'm going to look at the 7, 6 and say, here's 7, 6. Well, how many holes? Where's each hole? Well, 6, 6 is one hole. And then 1, 2, 3, 4, 5, 6. The next 6 or multiples is 12, 6. That's 2 holes, 2 hole sets. 6, 6 and 6, 6 is 12, 6. 7, 6 is one hole and some left over. So 7, 6 equals one hole and how many equal parts? One equal part over 6, one half. So it's 1 and 1, 6. Another way of doing it would have been 7, 6 minus 6, 6 equals 1, 6. So that meant I took out one whole and 1, 6. So 7, 6 is one whole and 1, 6. 1 and 1, 6. Just to show how to do this again, what if we were dealing with 9, 6? What if our answer was 9, 6 and we had to, what if the answer was 9, 6 instead and we had to reduce it or find it in lowest terms? I would look at it on a number line and say, well, 9, 6 is between one hole and 2 holes, 6, 6 and 12, 6. So I would say, well, going from here, I get to at least one hole. But then, how many pieces left over out of the next 6? 1 piece, 2 equal pieces, 3 equal pieces. So it's 1 and 3, 6. So 9, 6 would be 1 and 3, 6. That's how I show it if I have to show work. If I also had to show work for the adding part, I could do 1, 2, 3, 4, 6. Four, 6. And then I'm going to add 3 more, 6. 1, 2, 3. And here is my answer. Here is 4, 6. Here is 3, 6, which equals 7, 6. And that is what we got before, was 7, 6, which equaled 1 and 1, 6. So I like to use this number line to show my adding and to also show my fractions in lowest terms and mixed numbers. Thank you. This is Miss Johnson. Have a great day.